So that's a block attached with a string. Say this is M1. M1 is equal to 4 kgs. This is M2. M2 is equal to say 1 kg. And we are pulling it with F force. F force is say equal to 40 newtons. And suppose we are pulling this side also with, say this is F1, this is F2, say this is 10 newtons. So what is going to happen? Now two ways of doing it. We can consider both the bodies as one and take the net force and get the acceleration, which is the preferred way over here. Once we have ensured that both of them are going to go with the same acceleration, means this length of the string is going to remain the same. So if we are sure of that this is dragging it, this is always, this is always extended, not dragging, this is always extended, and the accelerations are same, you have A acceleration and A acceleration of both, then we can take the two masses as one and reduce our headache of writing a lot of equations. So what we consider this whole body as one body. When we consider it as one body of mass M1 plus M2, which is 5 kgs, then we have two external forces on it, F1 and F2, and we have none of these force, which is tension and all. So what's the answer in this case? The answer in this case will be, it is going forward. F1 is higher than F2, so the net external force is in the forward direction, which is 40 minus 10 is the net external force in the forward direction. The net mass of the body is 5, is equal to A, acceleration of the whole thing is A. So it is actually acceleration of the center of mass of the two things, which is A. But if this part is going forward with A, then this is also going forward with A, and this is also going forward with A, because this is always extended. So be careful over there. So what we have, A is equal to 30 by 5, which is 6 meter per second square. Now had we taken more tension and did through tensions and did the free body diagram of this and that and found out the accelerations individually, then it would have been done in this way, which is again not a bad idea to do by the way. It is not that I will not prefer doing that way. So let me write the equation. What we have, the forces on that body as F1 M1. I have not given you a lecture on making the free body diagrams. As we do the questions, you will see how it is made. It is simply looking just at the body and writing all the forces on it. So I am just assuming that it is on a platform which is horizontal, so the vertical forces are cancelled. Vertical forces mg and normal reaction is cancelled. Even though I should be writing, that will be useful, that will be used a lot when frictions come into play. So my fault, I did not write the vertical forces. I'm not going to write here also. So because I'm going to emphasize on some other point, F and sorry, this was tension at the back. We have discussed that tension will pull both the ends with the same vigor, so this T is equal to that T, so we have called it just T, not T1. So what we have is F1 minus T is equal to M1A. Now we know F, which is 40, we don't know T, we know M, which is 4, we don't know A, so we can't solve it. We'll write the equation for the other body. What is the equation for the other body? It has got F2 force backwards, and it has got tension force for forward, and this is M2, and it is also going forward with A acceleration. So what's the equation over there? Tension must be more than F2 because it is going forward, so T minus F2 is equal to T minus F2 is equal to M2A, same A as this one, because we have inspected that they are going with the same acceleration, so no need to put different variables. Otherwise this would have been A1, that would have been A2. Now T minus whatever we know, F2 is equal to 10 and M2 is equal to 1 and A is A. So we don't know A and we don't know T, but we have two equations, two unknowns. So how many number of equation? If we have n number of unknowns, we require n number of equations to solve it. Now if we add equation 1, say this is equation 1 and that is equation 2, 1 plus 2, if we add the two equations, what do we get? Plus t and minus t cancels, so you have 40 minus 10 is equal to 4 plus 1, which is 5a, which was ditto same as this equation. So we are going to get the same answers. What bonus we'll have is, once we have calculated the a, which is 6, once we have calculated that, we can calculate our t's. What will be the t? The t from any one equation will be equal to, here it is 10 plus 6, which is 16. 16 Newton is the tension. So this will be pulling it back with 16 Newton, pulling this forward with 16 Newton. You can cross verify by putting over here. If it is 40 forward, 16 back, so the net force on this, net force on that mass becomes 24 Newton forward. 40 forward, 16 back is the net force in the horizontal direction, and the mass was 4 kgs. So what will be the acceleration? 24 divided by 4. 24 divided by 4 will give you 6. That was the acceleration, 6.